Okay, this is a quick demo on vector addition. Basically, whenever we are given two vectors, oftentimes we will need to add them to find the sum of those two vectors, which is often called the resultant. So basically, just to give a basic example, imagine you have two vectors. We will call them, let's assume for argument's sake that they're displacement vectors. So you go on two different displacements. Displacement number 1 has a magnitude of 3 and a direction of 20 degrees. And displacement number 2, let's give it a different color, has a magnitude of, make it a little bit shorter, say it has a magnitude of 2 and a direction of 50 degrees. So how can we combine these two vectors and find your total displacement after you have gone on both of these trips, part A and part B of these trips? So the graphical way of adding these together, whenever you have a vector, is to take one of those vectors and, here, let me try that again, is to take one of those vectors and to, grab one of these vectors, drag its tail to the head of the second vector, and then draw a new line from the tail of vector 1 to the head of vector 2. So if we draw a new line over here, this red line over here, which we will call, the various vectors respectively, we'll call this vector A, we'll call this vector B, and we'll call this guy over here vector C. C is the sum of the two vectors because it is the result of what happens when you have displacement A and then followed by displacement number B. So that is the graphical way of adding vectors, but for us, we care way more about the way to do it mathematically. And mathematically adding vectors takes place in 3 steps. Step number 1, let's try that again. Step number 1 is to just resolve vectors into their x and y components. So we are going to take vectors A and B and we are going to resolve them into their x and y components. We are going to find the length of the x component of vector A and the length of the x component of vector B. We are going to find the length of the y component of vector A. And we're going to find the length of the y component, We're going to find the length of the y component of vector B. Let me just label this. This is BY, this is AY. This over here is BX, and this is AX. The next thing that we are going to do is we are going to add the x components and add the y components. So we're going to take the two x components and add them together. We're going to take the two y components and add them together. The reason why we are going to do that is because if you take a look, when you add the x components, let me try that again. When you add the two x components together, the sum of those two vectors is the x component of the red vector, of C, of our sum. We now have the x component of C. And if you then proceed to add the y vectors together, you will end up with the y component of C. If you just take a look, the sum of AX and BX is the x component of C. And the sum of AX and AY is the sum of AY and BY is the y component of C. So after you add together those two vectors, you now have the x and y components of C of our sum. And then that was step 2. And then step 3 is just to use the x and y components of the sum to get the magnitude and direction of sum of C. So once we have Cx, which is the sum of Ax and Bx, and Cy, which is the sum of Ay and By, we can use Cx and Cy to get the magnitude and direction of C. So what does this look like in action? Let's go through those steps one by one. So first step number 1 is to break down A and B into their components. A has a magnitude of 3 and a direction of 20 degrees. B has a magnitude, this is A. B has a magnitude of 2 and a direction of 50 degrees. So if we draw out A, we always like to sketch our vectors. So A, it's got a 3 over here, 20 degrees. So this is X and this is Y. So we're going to use a cosine function to find X and a sine function to find Y. Cosine of 20 equals X over 3, which means X equals 3 times the cosine of 20. Sine of 20 equals Y over 3, so that means Y equals 3 times the sine of 20. You take out your calculator and you type in 3 times the cosine of 20 and you get 2.8. You take out, and this is AX and this is AY, you take out your calculator and you do 3 times the sine of 20 and you get approximately 1. And you repeat the process for B. BX is going to be the exact same thing. BX is going to be 2 times the cosine of 50. And BY is going to be 3 times the sine of 50. 2 times the cosine of 50 is 1.3. 2 times the sine of 50 is 1.5. So that is, we have AX, we have AY, we have BX, and we have BY. That is the end of step number 1. Step number 2 now tells us all we need to do is add the x's together and add the y's together. So CX is going to equal AX plus BX, 2.8 plus 1.3, which is, it's going to be 4.1. CY is going to be 1 plus 1.5. It's going to be 2.5. That is CX and CY. That is the end of step 3. Step 2. Step number 3 is to use CX and CY in order to find the magnitude and direction of C. So in order to find the magnitude, we use the Pythagorean theorem. Again, so our C, it looks like this, and we have a line over here that is 4.1, and we have a line over here that is 2.5. So we're looking for the hypotenuse. So C squared equals 4.1 squared plus 2.5 squared. You add those two together and you take the square root. You do 4.1 squared plus 2.5 squared. Take the square root of the answer and you get C squared equals 23.06, which means C equals 4.8. That is our magnitude. And our direction, which is this angle over here. In order to find the angle, we need to use an inverse trig function. Since we are given the opposite and adjacent sides, we can do tangent and we can use opposite over adjacent. So we do tan -1 of 2.5 divided by 4.1. Plug that into our calculator and we get 31.4 degrees. So our magnitude is 4.8 and our direction is 31.4 degrees, which means our C up here, this red line over here, has a length of 4.8 and the angle that it makes with the horizontal is 31.4 degrees. That is how you add vectors. You resolve the individual vectors into their components. You add the x's together, then you add the y's together. That's what we did in step 2. And step 3 is you use the sums 4.1 and 2.5 in order to find the magnitude and direction of the sum vector, of the main vector, which you are looking for.